Okay, we considered the Atwood machine. I've sketched it here. We have mass M1G, M2G, both acting downward on these masses. And we choose a positive direction for the system as a direction of rotation in the counterclockwise direction. We go through the usual analysis, the net force being the difference of the two forces, M2G being the one that accelerates the system, or that tends to accelerate the system in the positive, M1 being the mass that tends to accelerate it in the negative direction. We get this net force. Dividing the net force by the total mass, we find the acceleration is this. Okay, the difference of the two forces divided by the sum of the masses. Question is, excuse me, what is the tension? To find the tension, we can draw a free body diagram for mass M1. We have a tension upward and a M1G downward. I posed the question of whether this mass, according to my picture, would be accelerating in downward or upward, and didn't get a lot of responses on that. But since the tension force is less than the M1G, it should be clear that according to this picture, which might or might not match the reality because we haven't specified these two masses, which one's bigger. But according to the picture that I chose to draw, the tension is less, so we would have a net force downward and an acceleration downward. Now, that would be the case if M1 was greater than M2. We don't know. Okay, in any case, we get the acceleration as net force over the mass. Acceleration of this mass, which I'll call A1, is F net 1 over M1. And F net 1 is just the tension minus M1G. And we divide that by M1 to get the acceleration, using the upward direction, in this case, as positive. For the system, we use the counterclockwise rotation as positive. For the mass, and for both masses, we're going to use the downward direction as negative, so upward is positive. And there's no inconsistency in that because when we consider the system as a whole, it's a different analysis than if we consider each mass separately. Okay, so each mass considered separately. A1 is this, and A2, we get an analogous result, tension minus M2G over M2. Now for the Atwood machine, we know that the masses go in opposite directions. So this A1 is going to be equal and opposite to A2. So we write A1 is equal to negative A2. So we set this expression for A1 equal to the negative of the expression for A2. We get an equation that we can solve for the tension. Having solved for the tension, we would plug that expression back in here and here and make sure that A1 and A2 come out to be equal.